Okay, that's better. Alright, so video number 159, it's Saturday. Let's go to the title screen. EDITCAM, still what we're working on. However, this is not 85, this is part 86 now of our PAINT5D sprint. Not much of a sprint anymore. It's more like, we are on 159, and this is part 86, so what does that make of everything, right? 159 divided by 2. Yeah, so more than half of our videos have been this quote-unquote sprint of the PAINT5D system, right? So even though right now this video is titled EDITCAM, this is kind of like EDITCAM is kind of a subtask of PAINT5D, right? So the main project is AAC 2020. The sub-library that we're focusing on is PAINT5D, but we're currently working on EDITCAM to make camera controls a little bit better within the PAINT5D system. So the first thing we want to do is just grab our bearings here, right? So we just want to compile and make sure that everything runs. Like, make sure it compiles and make sure we're starting at as we start trying to add more code, we want to make sure that we're working on a solid foundation, right? So we don't want to be adding code if we're currently not compiling, right? So here we go. So Y and N, and we can zoom in here. Zooming in is very slow and tedious. And then once we're in here, we can zoom, or we can do I, J, K, and L to kind of like scroll over this data here, right? So that's kind of cool. And so the next thing we are concerned about is I want to be able to do this kind of stuff without having to use the keyboard, right? I should just be able to like click and drag to move around, right? And then the zooming needs to be a little bit faster as well. So, so yeah, right now that's not what we have. So I would like to work on that. Okay, so let's get to that, right? So I have no clue what just happened there. So, iMouseBox, let's close this. EDITCAM is what we're focusing on here. And particularly, what do we want to do? Well, let's close F macros. Let's keep this one open. We have way too many things open, but, okay, we got this snapping code. And where do we use the snapping code? We used it here. So, snap camera span. Okay, got it. Makes sense. Now, do we use this anywhere, though? Nope. Okay, so let's go find out where we're using the camera controls and stub in this friendly camera control where it needs to go, right? So, we know it's like, it's for the mouse, right? The mouse is, the mouse controls is where this is kind of going on. So, tau type will probably have to be used. Genuine, Genuine we want to focus on eventually again, but let's close that for now. So PAINT5D should have like a mouse input, right? So F mouse in, or mouse in, should have like a mouse input handler. And yeah, mouse input handler, Mowin, right? And here we have getting viewport 0, okay? viewport 0 is the destination viewport, right? So this is kind of figuring out where we're clicking, right? Is click within canvas bounds? Yeah. Okay. Inbound actions. On mouse scroll. Okay, so we got PAINT5D zoom camera. And what we're going to do here is we're going to go find PAINT5D zoom camera. And we're going to make... we're going to make something like that, but it's going to... So this is a zoom out, right? Okay, let's go find zoom camera for a second. So we could use the keyboard with the normal zoom camera. And... right. So here's what I'm going to do. I'm going to indent this because I'm going to make another zoom camera. And I don't think it's going to call this, but it's going to be like a zoom camera that is... it's going to be more friendly, right? So we're going to call it void AAC 2020 PAINT5D zoom camera. And we want to do, oh no, do we want to call it zoom camera EDITCAM? Right, so it's like an overload that uses the EDITCAM namespace. I don't know. So how about zoom camera use EDITCAM, right? So this is an overload that uses EDITCAM, right? And we're still going to do an int32, right? Zoom int32, and it's still going to take a zoom value. It's just that it's going to scale the zoom amount by something, right? So it's going to make the zoom more extreme. So let's rename that just started so that we can pull this into it. Okay. So before we zoom pull it, we want to know so I think at the end we could say so I'm thinking at the end we're going to do this zoom camera up here. We're going to use this modified value, right? Yeah, let's just call this zoom camera, this section here. And Right, because these are both the zoom camera stuff, right? Okay. So what we want to do here is first we just want to be able to get the, come on. We want to just be able to get the, so if we go into Tau Depot, functions, right, we want to get this. This is how we get the rectangle, right? So, okay, Tau Depot get, and we're going to get VP1, right, the off-screen viewport. So VP1 means, right, so let's make a note of this. So it's important to know what this viewport is. So let's make a note of it right here, right? Okay. So the reason I gave viewports numbers rather than names is because after a while, coming up with names for all the different viewport types with all the rectangles is getting kind of annoying. Even though it is harder to read because you have to keep on reminding yourself, okay, what does this number do, right? And that's kind of annoying. But it's nicer when you get a whole bunch of different viewports, it starts to be like, it really wrecks with the regularity of your code when you start coming up with all these fanciful variable names for different kinds of viewports, right? So we have many types of explanations that we can use for what we mean by VP1, but we'd like all those different kinds of explanations to converge on the symbol VP1, right? So in our brain, all of the different associations can converge on VP1, and that will actually help make the code clearer, if that makes any sense at all. So yeah, we gotta use Tau Depot get here. And we need to say, you know, int30 u32 x0, right? Right. So you have to create all these variables, x's and y's, zeros and ones, right? And bounds of right. So this is min x, this is max x, right? If we want to explain this, this is min y and this is max y, right? I don't have to explain it, but it's like, since I have room to kind of explain that, I might as well throw in an explanation, right? That is kind of where I'm coming from there. So then we can just, I don't know. Okay, so once we've gotten this, we want it to assert that it's square. So, let's just do u32 width equals x1 minus x0 plus 1. And then height, same deal, right? So height, the bigger y minus the smaller y plus 1. And if width is not equal to height, error, problem, camera is not perfect square. ERR, let's just call it ERR, camera is not perfect square, right? So we're assuming it's a perfect square. And then what we're going to do is we're going to snap the camera span, right? So, int32 san equals int32 cast of width or height, right? We don't really care which one it is. And this is my way of saying it's an arbitrary selection because both of them are equal, right? So width or height. Okay, once we have the span, we're going to take this snap cam, and we're going to use okay, we find the old span, we get the new span, and once we have this, we can just use the old camera controls to, well, hold on. So before we, so we're going to snap the camera, right? And then what we're going to do is we're going to put the, we're going to, get camera and snap. So we're going to snap the camera to a friendly size. That's what's going on in here. So all this stuff. So once we have the new span, we want to know how different that is, right? So we got old sand, we got new sand. I mean, technically we could call it sand old and sand new, but this reads a little bit better as English. Also, I do like the fact that if we want to, like, truncate this, we can just call it old and new, right? We can just call it old and new and forget about the redundancies here. But, I mean, we could definitely do it the other way around, though. I mean, we can... I don't know. Let's just make a note of this. So, if that's what we're going to stick with, that's what we're going to call it, that's fine. Well, hold on here. Do we want to call it old sand or do we want to call it sand old? And sand new. I think that... I get that it reads better that way, but... we've been putting the deltas on the end and going from general to specific, so we should probably stick to that, right? General to specific. Even though, like, I have the... It does read better as English, but... Oh, I see. So, cam span here. Camera span. Well, camera span. Sure, we can do that. Let's go look for cam span for a second. Make sure that's not a variable already. Yeah, cam span, and then if we do sand cam, it's backwards. So what we're going to do here is, sure, that's fine. And then we have outspan. We have outspan, we have max span, we have... I guess since we're writing it this way, we might as well do it the other way around and say... So an old sand means old sand means old sand means. Okay, so old sand and span is where width equals height, right? So let's just take this and let's look for old. And let's just replace it with new. Oh god, wrong thing. Okay, yeah. So we got new span and old span, right? And then that means that span new is going to be the wrong way, right? You know, generally I like general specific. I like way around. So the important thing is just to pick one thing and kind of stick to it. So I'm going to stick to that because I'm going to stick to this because span at the end, even though that's not general to specific, I mean, you could say it's general to specific because old and new are more general than span, right? Max and min are more general than delta, right? Span is right? General to specific is kind of subjective, right? So in the end, we just want to make sure that if we use the token old san, if we decide that, hey, you know what, old san is what we want to use for the variable name, right? We want to use this. Then the most important thing is just never to use the inverted version where we do san old, right? So that we can find this variable everywhere in the code. So, okay. So we got san old, which is just an int32 cast of the width and the height variable. And, also, if x0 is greater than x1, error out of order x0, x1. Okay, that's doesn't quite fit. Let's just remove this. And then same thing with this. If the y0 is greater than the y1, then we're out of order as well. Okay. Okay. We want to take the old span. I'll take the old span and convert it to this new span. And then, we want to cam not perfect square. After we have this, and we snapped this, right? Then we want to, then what we want to do is we want to, the pixel step is going up, right? Then okay, well, so we don't want to go to the next power of 2, right? So this camera exponent, right, we got this lookup table. And lookup table picks step up. Let's go look at that. Yeah, I mean, we could find the next power of 2, right? We could find the closest power of 2. And then use this to decide, we could find the closest power of 2, yeah. Oh, hey, sorry, yeah, I am working on some camera controls, yeah, I'm working on some camera controls to make things a little bit smoother. I think I've described this before. I don't know if I've described it to you, though. So say you're, like, in a spaceship, right? And you're headed towards, say, I don't know, the sun. How about the sun, right? And as you launch from Earth in your spaceship and you start going towards the sun, and let's say your spaceship is going at a constant rate of speed towards the sun. Well, for most of your journey, it's going to look like the sun is just not moving at all, right? It's just so big that it's so big and it's so far away that it doesn't even change size as you're moving towards it, right? And then as you get closer and closer, the size increase starts to happen faster, right? That visual size increase starts to happen faster, right? So once you hit the sun's atmosphere, all of a sudden, everything starts getting a lot bigger, a lot faster, right? So the importance of this with zooming controls is that when we're zoomed all the way out of the canvas and we're trying to zoom in, we need the camera to zoom in faster when we're further away, and we need the camera to zoom in slower when we're closer in, so that the perspective effect will be canceled out, and the zooming will actually be, will seem more linear, which is kind of weird to say the zooming will seem more linear. So mathematically, the zoom will be kind of like a, won't be linear. We're going to use like an exponential zoom, but that will cancel out the exponential perspective effects, right? If that makes any sense. I can actually show you what I mean by that. but I have to comment some code out to get that running first. So if I go into here, let's just do a no op on this for a second. So if zoom I32, or just say no op. Okay, and then we're just going to comment this stuff out for now. Okay, so let's give this a run, and I'll show you what I mean. Because currently the camera control is not very nice, and this will help explain. What I mean by canceling out the zoom. Okay, so right now the camera zoom is completely linear, right? So okay, so the camera rectangle is going to increase. Is going to shrink by 1 pixel, right? So when the camera rectangle is gigantic, it selects over the entire data set, right? And so we're zoomed all the way out. If the camera rectangle is very small, then it is sampling from a very small subsample of the data set, and therefore we're zoomed in. So we're going to zoom in linearly, and every time we zoom in, the camera rectangle shrinks by 1 pixel on each side. So if we do this, it looks like it's going very slow, right? Like I keep on scroll, very slow, and then all of a sudden as we get in here, right, now it's like this looks very fast, right? This is very fast and nice, like this is nice right here. And the reason why this seems so fast, it seems like our camera speed has sped up, but it hasn't, right? It's the perspective effect, right? We've kind of entered the atmosphere of my tile set. You could think of it in an analogy. But right, so this is 1 pixel, this is 1 pixel, this is 1 pixel here, right? So every time we zoom in and out, we're going by 1 pixel, but since we're zoomed in so far, 1 pixel is very big, so it looks like it's going faster than it is. As we zoom out, the individual pixels get smaller, and so the zooming starts to look like it's going really slow. So we need to cancel out this effect, right? We need to cancel out this perspective effect to make the zooming more user-friendly, right? Because this is painstakingly slow right here. Like, this is annoying. Like, this zoom here is not actually useful to me, right? So to do that, we need to zoom by more when we're out here, and then as we get further in, we zoom by less and less. So once we zoom in here, we'll keep this 1 pixel zoom here, because this is fine. And then when we're further out, we'll zoom by, 32 pixels, 64 pixels, some type of power of 2. So that's kind of what I'm working on there. So I'm not sure exactly how I want to do this, because I wrote some code for it last night, but it's kind of like I'm sketching out the idea. So, right here is where we fetch the camera rectangle from the texture memory, right? So I'm storing the camera as a cluster of pixels on a texture, and we fetch the x lower and upper bounds, the y lower and upper bounds of the rectangle. And after we fetch these, we want to make sure that that rectangle is properly ordered. So the lower bound should be less than the upper bound, and the right for both of these. Now it can be equal to, but the x0 should never be greater than x1, right? And the y0 should never be greater than y1, right? Because otherwise our rectangle has been inverted, and then it's not a properly conforming rectangle struct at that point in time. So after that, we want to look at the width and height, right? So it's an inclusive rectangle, so we minus the upper bound and the lower bound from each other, and then we add 1. So imagine that x1 and x0 are both at 0, 0. Well, then we want to add 1 because it's a 1 by 1 pixel region for the rectangle. Okay, so after this, we want to make sure that the rectangle is completely square, because for our camera code, we're going to assume a square camera. And for some of the logic down here, this logic is operating on one variable that represents both the width and height of the camera. So We're going to take this old span and we're going to snap the camera. And let's go look at the snap camera code. So snap camera. So we're going to snap to whatever is closest, right? So we're going to snap to the closest value in a lookup table. And if we look at this, we can see that this is snapping to, oh, we have min and max. So this is using this table, and this table is table of zoom span. And let's go look at that. So it's this thing here. So these are kind of all the increments that we want to latch to, right? So I think the first thing is we want to snap to this. And then I think the next thing we want to do is get whatever comes next. I think I want to rewrite this because I want to know where this is coming from, right? So I want to know what index am I actually using to snap here? So let's just modify this, I guess. So let's change this. So let's just modify this up a bit. So anywhere where I see camera span, I'm gonna put old span, right? Because it's right. So that is so here's the old span and here's the out span. Actually, hold on. Let's think about this for a second. So outspan is going to be called new span. So anywhere we see outspan, we're just going to call it new span. And then we're not going to use a return like this. We're going to return using some output parameters. So we're going to do something like, we're going to say by ref and then we're also going to do so I want to know what index as well. And this is kind of ugly, but let's just roll with this. So return via output. We don't want to make things more complicated than they have to be. And we don't want to have to recompute stuff if we don't need to. So some of the ways I was thinking of doing this were actually more convoluted and harder than they needed to be. So even though the signature is going to be kind of weird because we're going to return this, and we're also going to return this index, it's going to be better that way. So right here, this camera span, I can still call it cam span, right? So this is the input span. So this is in span slash old span, right? And then we have int32 by ref, and we're gonna call it out span. And then we have int32 by ref out dex. So do we wanna, how do we wanna do this? So I'd like to line up everything kind of nicely if I can. So I'm gonna put this over here. Okay. Output span. And this is okay. So we're gonna use these. And the output index is going to tell me what index I actually grabbed out of this table, right? So we're just going to say, you know, outdex equals 0, right? So the idea is that the output index is the same index that we're using to grab here, right? Now we could declare outdex. We could set outdex like up here, and then we could use outdex in here, but I don't know. I think it is a little bit easier for me to understand by just lining it up kind of like that. And then we're going to do int32 outdex here. 0 minus another trap value. Output index accessor. To table tab, right? So this table right here, it's going to be an index accessor into that because I want to know where we're positioned, right? So this function is going to give us one of these values here, and I want to know where we're positioned index-wise, so that we can either jump up or we can jump down, right? That would make it easier to just go to the next value, right? So we snap the camera to whatever one of these is closest, and then after we snap the camera, we decide, okay, well, what's the next thing above or below to where we want to go, right? So having this output dex will help with that, right? So anywhere where we're making a decision to grab the output span, so anywhere we decide that we want to set output span is where we need to also set this output index. So output span here is going to select between one of these, right? So now, in order to figure out the index, we can just kind of hackishly say that, you know, if let's say outsan plus 0, and we're going to do plus 0 so that we don't accidentally do any assignments, right? Equals maxsan plus 0, right? Else, if outsan plus 0 equals maxsan plus 0. So once again, the plus zeros are just there to make absolutely sure we don't do any accidental assignments. Okay. So for these, right here, if none of them are equal, we have an error. So neither max nor min match. 2021. It looks to me, oh, it just fits. Okay. So max and then min span needs to go here. So min span. Okay. And if it's equal to the max span, then max span is the dex plus 0, right? So for the out dex, hold on. You have this dex. Oh, this dex is local. Out dex is not local to this. Okay, I get it. So, so out dex equals, for the max, dex plus 0, right? And then over here, the out dex equals dex plus 1, right? So we're just saying that the value that we have for this span was either gotten from here, or it's gotten from here, but it's kind of complicated because we don't know, because we select between these two things, this or that, right? So we want to snap this camera value to either this min value or this max value, and we don't know which one we're going to select yet. So, the min span is further down, right? So further down we get lower values, higher up we get higher values. Okay, yeah, so now we have this output dex here, because we did out span here. Anywhere we do assign output span, we also want to assign this output index, all right? Where we see this cyan, we also want to see this orange. So we see the cyan here, we see the orange here. So then here we have, if it's not found, if found is less than or equal to 0, so found equals 1. Okay, yeah, so if we're not found, then we're going table dex minus 1, right? So the out dex equals, right, we're just going to say dex minus 1, right? We're just going to keep the exact kind of accessor there. Okay, so now that we have that, you know, we're returning them here, but we're not returning dex, though. We're returning out dex, so out dex, okay? And these are all int 32s. Okay. So let's clean this up maybe just a little bit more. We're going to declare some variables in this section, right? That's what we're doing here. So let's keep everything kind of nicely organized here. So I have like more scopes than is necessary, right? Because this is not a scope enforced by the language with like a bracket. It's when I make a section divider like this, I also indent to make it more clear what code belongs to what section. Now this might be kind of hard because if we try to indent this, this is already kind of like, whoa, way kind of like out there. So we might not indent this. We might just make a section and say, you know, main function logic. We could just call this main function logic and give it kind of a bolder divider. You know, it's kind of ugly. It's not the best, but it's better than what we had. So, just sectioning that off so that when we look through this, we can easily click here, go, oh, variable declaration, okay, main logic, and we can look between here to look at the meat of the algorithm, and then return via output parameters. So, like, we have everything kind of compartmentalized nicely. Also, this output index should, if we count these values, I mean, this is kind of painful. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 26, 25. So 26 is, there's 26 valid entries, and the 27th is a null terminator, right? So, assert that the outdex is greater than or equal to 0, right? So 0 is valid, and outdex is less than or equal to 26 minus 1. So, oh, actually, and we also want to assert that this with the outdex, right? So whatever output index, we want to assert that I want to make absolutely sure we don't have an accidental assignment, so I'm going to say this. Equals the output span. Right? So we could just do that, and that would be fine. So just make absolutely sure the value we fetched, can be retrieved using the index output. So this is kind of like this is kind of ugly, right? Where it's like, this function has no encapsulation, right? Alright, so this thing here, hey, how's it going? So actually, let me explain what I'm up to. Since you're here, I might as well explain what I'm up to. So let's comment some stuff out. Let's try to get this compiling. Hey, anime dude. Man, I'm in the middle. Okay. Where am I in my code? I guess we just try to compile and then see where it breaks. That might be a good way to go. Let's do that for now. Actually, because I know I'm already over here. Okay, so it's this code I need to comment out really quick to show you what I'm up to. Oh yeah, let me. I can show you this really quick. I'm just gonna comment this out so I can show you exactly what I'm up to. But I understand, like, when you're coding all the time, you don't really have much time to watch other people, right? So that's kind of like, I kind of like hop in to your stream once in a while. I get how it goes. So define air, we're gonna say AAC 2020. EDITCAM halt is the air function for here. Let's go down here and let's define or undefine this. So undef air. And let's just try to get this. Let's just try to get this damn thing compiling so I can show you what I'm up to before your 5 minutes runs out here. And if not, I might not be able to get this unbroken by the time I want to show you this. So EDITCAM F175. Control reaches end of non-void function because I wanted to make this void for now. I'm changing around the signatures. Ah, no, it's just family stuff waiting for the wife and kids to come home. Oh yeah, I got ya. Okay, let's see. Okay, there, we're compiling. Okay, cool. So now I can actually show you what the heck is up here. So let's full screen this. And so right here, I think you've already seen this. I don't know. This is just the memory view. So instead of using uniforms, I am using texture memory, right? So I am packing all of my uniform values into unsigned 32-bit integers and just throwing them into pixels on a texture, right? And so this is just my debug to be like, hey, are all my variables on the GPU like I think they are? Which, this is complete craziness, but that's not what I wanted to show you. So let's go over here. Okay, so the zoom here right now seems kind of slow right here. So I'm using the mouse wheel right now. And as I zoom in here, it's going to get faster, right? So here, this is pretty fast, right? And the zoom rate is actually completely linear. It's just that as you're zoomed in, right, this is 1 pixel, right? And the camera is shrinking, is either contracting or expanding by 1 pixel on each edge, right? So the camera this looks more, what do you call it? This looks like a faster zoom, right? This looks like a fast zoom, and then way out here looks like a very slow zoom, but it's a linear speed, right? So it's like, the analogy I keep on using is like, if you were to like go in a rocket towards the sun at a linear rate of speed, at first it would look like the sun isn't even moving, right? Because you're so far away from the sun. And then as you get closer and closer, visually it's going to look like you're speeding up, and then you get into the atmosphere of the sun, and all of a sudden like everything seems to be like moving past you like really fast, right? Or same thing with like parachuting. from like a very high distance above the Earth, right? So we want to cancel out this effect here, right? We want the zoom to seem more linear, and ironically, to make the zoom feel more linear, we actually have to make the zoom exponential, right? So we need an exponential zoom to cancel out the exponential perspective effects of what we are observing here, right? So that is what I'm working on right now. And so that's only the interesting thing I have to show you. That's all I got. But yeah, so to cancel that out, though, I can show you the data for this, right? So the camera rectangle right now can be between 2 by 2 and 256 by 256. For this current camera rectangle, the largest rectangle that encompasses all of the data is 256 by 256. And when we're zoomed in really tight, the tightest zoom we can have is a 2 by 2 rectangle down here, right? So this is basically all the increments that I want to hit when I'm using the mouse wheel, right? So at first, when we're zoomed in really tightly, we're going to just zoom by 2 pixels, right? So a very small zoom. So 2 pixel zoom means that on each edge of the camera, we're going to expand or contract it by 1 pixel, right? Because to make sure the camera is centered, we have to squash and stretch the edges of the camera by equal amounts. So the minimum amount of zoom we can have if we're going to use discrete units is 2, because one of those is ones is going to be distributed on the left side of the camera, and then another one of those ones is going to be distributed on the right side of the camera, and then for the top and bottom, same thing, right? So that 2 gets split apart to the respective edges, right? So then as we start to zoom in, as we start to zoom out, so right here, as the camera gets bigger, the steps also get bigger, right? So when you're zoomed out, when you're completely zoomed out at 256 by 256, you want the zoom to be more extreme, so we have units of 32, right? And then when the camera is 128 by 128, we zoom in by 16 increments. When the camera is 64 by 64, we're zooming in by 8 by 8, and when it's 32 by 32, we're zooming in by 4s, and we're like between 8 by 8 and 2 by 2, we're zooming by increments of 2. And the math kind of works out nicely, except this little hitch here, right? You can see that these numbers, we have like 4 numbers here, and then we have what, like 6 numbers here. So the distribution here is kind of wonky, but then after we get out of that, like all these are nice chunks of 4 numbers. And that's kind of weird, but that's also why I made it in a lookup table, right? Because since I have a lookup table, I can have this wonkiness and it's still going to work, right? But if I tried to like completely formulaically solve this kind of ramping, where I made like a formula to say, here's your current camera size, and figure out how to like ramp to the next camera size, right? Using some type of inverse exponential wacky, crazy formula, that would be quite difficult, and it wouldn't even work because we need a formula that isn't completely right? There's a smooth data transition here, right? But then over here it's all wonky, right? So there's no formula, there's no kind of like linear transformation where we could put an input in and spit out exactly what we want. So so these are just numbers that I kind of like got from eyeballing and then just trying to get things to fit into powers of 2. And so this table is kind of like slightly empirical and then slightly theoretical. So yeah, that's what I'm working on. So that's just the interesting parts. Everything else is just going to be kind of boring. But yeah, and also is X Jones still around? So speaking of that, let me see if I can find something for you. I know I've probably shown this to you before, but That's not the one I wanted.
Yeah,
Now that's more of the serious one. Like there's actually some like research. I was looking into the actual legitimacy of that. It's not really about gay frog. It's actually about hermaphroditism. Man, I cannot pronounce that. Certain chemicals causing hermaphrodit. I can't even pronounce it. Maybe you know what I'm trying to say. But yeah, it's not actually about, like, when you look into what Alex Jones was talking about, there is like a crumble of credibility, but it's like right to any good conspiracy theory, you have like little what do you call it, nuggets of truth, right? Like the best conspiracy theories have a little bit of credibility, right? And that's because if they don't have any credibility, then you can't get people on your batshit crazy bandwagon, right? But that wasn't what I was interested in. Let's try Gay Frog's Techno. No? Seriously? Is this not a shortcut? Because if this is not a shortcut, this needs to be a shortcut. Now, it could be a shortcut, and I just haven't reloaded my shortcuts since I made this. What? No? Okay, so we're gonna add this right now. So I need to go to the top of my shortcuts, pay no attention to anything that might look political, because I'm sure there's political things in here. Don't cancel me, etc. Gay Frogs Techno, Gay Frogs Techno. And we're gonna go find this, because I know I already have it. It's just that I need to go find it for a second. So let's go put a bookmark here, and then go look for Gay Frogs. Gay Frog's a deep dive. I would say that's more of the serious thing. That's not what I want. Maybe I need to look for Gay Dash Frog, maybe? I'm gonna find this. I know it's in here. It's like frog research. Okay, you know what? We're just gonna have to go find it on YouTube again and just bookmark it again, because I know that if I look for it, I can find it really quick. Let's just do Gay Frogs Techno, right? And try to find the... I want to find the original, though. Are we on... I'm gonna go look through my internet history, but I'm wary of what's in my internet history, so I'm gonna put this on another monitor really quick. And I'm gonna look through my history, because I know this should be in my history, I just don't know... Aha! Found it, I think.
I don't like them putting chemicals in the water that turn the friggin' frogs gay. Do you understand that? Turn the friggin' frogs gay. Serious crap. Gay. Frogs, friggin' frogs. It's not funny. I'm gonna say it real slow for you. Gay. Frogs. Won't you fight for your life? Gay. Frogs, friggin' frogs. I don't like a frog. Gay. Friggin' frogs. Frogs. Friggin' frog crap. Won't you think of frogs? It's not funny. I'm gonna say it real slow for you. Frogs.
Okay, so...
Place point.
Okay, there we go. Okay, found it. Anyways, so, I made more shortcuts so that, you know, next time I can find that. Oh, hey, I can send that to you really quick. Actually, I should have put that. I should put that in the cringe group. Hold on. Let me go to Discord for a second. My shortcut for Discord is called Josh Chat because the original reason I have Discord is so that I can use Discord to talk to my artist. So let's just throw this in here for a second. I don't know if it's cringe, but hey, I'm just throwing it in here because this is where I'm just going to throw stuff I like until you slap me on the wrist and say, put it somewhere else, and then I will put it somewhere else. But there you go. Now it's there. Alright. Yeah, so I'm going to put this back up here for a second and get to doing what I was doing here. Yeah, so yeah, what is the... I can't believe that Luncho isn't part of the Discord. I don't know how to use Discord very well, so somebody get him that invite, or I'll try to figure it out later. But I think that Don probably knows what to do there. Otherwise, I'll figure it out later for you. Okay, so we kind of changed some things around here. So we got this zoom int32 value, and let's just remove this no op for now. We'll get rid of it completely later. So right here is where we're pulling the rectangle off of the texture memory. So these variables here are just to isolate certain subsections of the texture memory. So some bounds checking. Okay, so this thing needs to be changed, right? Because if we go into the EDITCAM, we have changed around the signature to be a little bit weirder. So because I am trying to do a data-oriented design, or maybe I'm just a lazy person who has no structure to their code, we're totally violating any type of encapsulation right here. But technically, if we look at this, this table is an uppercase namespace, right? So if it's an uppercase namespace, the idea of that is that it is conceptually public. So technically, if you want to get really technical, I'm not actually violating any encapsulation here. But anyways, this old span and this span new here, we don't want to do it like this anymore. Equals 0 minus 747, some type of trap value. So when I say trap value, I don't actually know the correct way. Like, I think there's probably another definition for what a trap value is. But for me, a trap value is just a value I intentionally set that it's an obviously wrong value, so that if I forget to set this to something meaningful later, I can kind of see it and be like, hey, 747 negative, that sounds like some BS that I put in the code, right? So we're just going to return this by an output parameter rather than a argument. And then we also need the index. So we got this output span, and then we have this output dex. So we're just going to say sandex, I guess. It almost sounds like I'm violating some type of copyright. And then this is a straggler. Let's get that out of there. And int32 sandex equals, I don't know, 0 minus, how about 474? Right, another trap value. And so usage, we can make a note of the usage here, right, which is that we're going to take the usage for this is sandex, right? Let's just remove the... I don't know, that's a bit long. Do we just want to remove the namespace here? I think it just needs to be enough where I can see what I mean. And The library namespace is basically on everything. So, I mean, let's just remove the AAC 2020 namespace, because the commentary just needs to be enough so that I understand what the heck is Sandex for. Well, the usage is this, right? And then, now that we have this, we've snapped to the, snap camera size to a pre-approved size, right? So we're snapping the camera to a pre-approved size, and then after we snap the camera to a pre-approved size, we're going to, we are then going to, get the next camera size up or down, depending on if a positive or negative value was supplied. So, over here, yeah, I know, like, the first time I, the first time I saw that video, like, I could not stop laughing. And it's like, not to get too depressing here, but, like, as the older you get, I think that, I could be full of BS here, but I think that as the older you get, you kind of lose dopamine receptors, right? That's why, like, old people are always cranky. But it could also be that as you get older and older, there's less new things to make you awe and whatnot. So I find it happens less and less that I find things that actually make me laugh out loud, and that was one of the things that made me kind of laugh. So just need to bring joy to the world, and it's harder and harder the older I get. Which is one reason that I drink coffee only on Mondays, right? So the idea is, if I drink coffee only on Mondays, I'm always in a good and productive mood on Mondays, and then every other day is just like, I hate everything, but we must struggle on. Okay, so, right over here, we're going to just, we're just going to do an assert here. And we're just going to assert that, 1 or 0 minus 1 equals zoom I32, or 0 plus 1 equals zoom I32, which is kind of weird. The reason that I have this, like, zoom camera function that takes either a 0 or a 1 is just to, I want to avoid the proliferation of function names if I can. So by doing this, I only have one function call, rather than, I don't really want a zoom camera in and then a zoom camera out, or a zoom out, zoom in. It's also just because I am kind of OCD and I really like symmetry in my code, right? So a zoom camera function that can have a zoom in or out depending on if it's given a negative or a positive is, to me, a very symmetrical way of doing things. So I just, look, I'm batshit crazy. I don't know what to tell you. So anyways, we're just going to make sure that this is a 0 or a 1. Value is only used to signify if we are zooming in or out. Okay. And honestly, I forget if it's a positive that needs to zoom in or if it's a negative that needs to zoom in. I honestly forget. So we're going to look at the zoom camera. We're going to have a breakpoint here and look at zoom camera really quick and figure out what the convention is. So we don't want to use one convention in one place and then another convention somewhere else. So we can see that ZO is for zoom out, right? And ZI is for zoom in. When the mouse wheel is going negative, it's going towards the user. Okay, then we're going to zoom in, and this value is the mouse wheel. Too much indirection here. Oh, actually, we have this commentary here already, though. So let's just make some more comments here, right? So 0 minus 1 is out, right? So let's just say negative, right, equals out, right? So we can see negative is zooming the camera outward, and then positive equals in, right? So just making sure that we know how that convention works, right? And then we can go back to the function, and now we remember that negative is out, so zooming out. So, right, so zoom out is negative, right? Negative is out. We can just make a comment here, negative equals out, and then, you know, positive equals in. You know, while we're here, I might as well add that commentary. Okay, so now that we know that, let's just make the note here as well. Negative equals out, and then positive equals in, right? So let me double check that, make sure that I haven't gotten that wrong. Negative equals out, yeah, negative equals out. Okay, cool. So now that we know that, we can figure out what to do here, right? So if the zoom I32, so if zoom I32 is less than 0, right? So negative is out. Okay. And then else, if the zoom I32 is greater than 0, then that's positive. That's inward zoom. That's zooming in. Zoom out. And this is zoom in. And then otherwise, I do something called defensive programming, or maybe it's actually called offensive programming. So offensive programming is a subcategory of defensive programming, and I write my branches quite a lot like this, where if this case, and then rather than doing an else, right? So if this, or if this, and then else error, right? Because I could actually write this as like, you know, well, I guess 0 isn't valid, so, but pretend that we have a value that could be less than or equal to 0 or greater than or equal to 0, right? We could just make this an else rather than an explicit condition, but I like to always have the last else be something that throws an error, right? So it would be the same thing if I was to do this as a switch statement. Well, actually, this isn't a compile time constant, so I can't. But in a switch statement, the same thing. The default case, I want to throw an error. That's just the way I do it. Okay, so I'm just going to say not zooming in and not zooming out. Some type of error message. It's a little bit too long, actually. Not zoom in, not zoom out. Year 2021? Maybe? Yes, okay. So, with the error message, I really don't care what the error message is. Honestly, the most important thing for an error message is just that I want to try to make the error message unique to the entire code base. So, one way I do that is just tag the error message with the year. So, as long as I am creative enough for the entire year, then that's for, I only have to be unique for 365 days in a row, and then after that I'm in the clear, right? Because then I can just tag it with the next year. But an error message to me is just a way to bounce back into the code exactly where the problem is happening, and then go look at the code and fix it, right? So the only use of an error message for me, or at least we're talking about fatal errors. A non-fatal error is a different scenario, but for a fatal error, the purpose is just for me to be able to get back in the code and figure out where it's happening and fix it. And so it doesn't really need to be an informative message. It just needs to be a message that gets me back into the code at the exact point where things are happening, which is probably totally unconventional, because if you look at like Microsoft C#, right, they have all these like error classes and error categories. Same thing with Java, right? They make their error categories way too granular. I think it's insane the way they do that. There's only 2 categories of errors as far as I'm concerned. there is a fatal error that needs to crash the system, and then there is a non-fatal error, right? A non-fatal error would be something like somebody unplugged the USB stick while you were saving data, and it's not a fault of the program, it's just it was an error that was unavoidable, right? So if there's an error that can be triggered no matter how good of a programmer you are, because there's some type of external force that is creating that error, that needs to be a non-fatal error, right? So an IO error, right? And then if it's an error because the programmer is being stupid, well, then that's a fatal error, right? So only 2 categories of errors as far as I'm concerned. Yes, I'm highly opinionated. I'm highly opinionated, but don't think for 1 second that I think I'm like super smart or some type, because I know a lot of people will think that I'm like pretentious and stuff. No, I don't think I'm that smart. I'm pretty average intelligence. It's just that I've been writing code for a while, and so I have very specific ways I like to do things. Okay, so we got this zoom in, zoom out thing. How are we going to do that, right? So, well, we have this index, right? So if we are zooming out, let's look at this table here. A zoom out means we need to get bigger, right? So we need to take that that dex, right? That sandex, and we need a plus plus, right? So you're pretentious? Maybe I gotta watch your streams more. Yeah, like let's see. I honestly, like, if I were to typecast you, I would probably say what do you call it? What's that thing that they, I don't know. I'm just gonna say it and then I'm not gonna go any further because I think it could get political. But what do they call it? They call it a coder bro or something like that. And I don't mean that offensively. I just mean that you seem like a normal person. I mean, well, I'm sure that if I watch you more, I'll realize that you're not. Or like you're either a normal person or you're really good at acting normal sometimes. But I knew this really I knew this really popular guy at Digipen, and we called him a coder bro as well because he was like just really popular, and we all went to his parties and all that kind of stuff, and so we also like would call him like a programmer bro. But this was before things got political with that phrase. So it was like at that point in time. Right, this was like 15 years ago. It was not like being used as a pejorative. It's just like, hey, you just happen to be kind of like a jockish, popular kind of person who is also a nerd, right? That's like the vibes I get. Yeah, programmer. Yeah, programmer. That's what I was thinking. Yeah, programmer. Yeah. So like, yeah, and this is just my all right. See ya. Yeah, but that's just my train of thought. I mean, so I've been, my artist said once about me that, like, he said something like, John Mark, the first time I saw you, I thought you were a total jock, and then I heard you speak. Because, like, back in college, right, I wore, like, a lot of muscle shirts, and I did gymnastics and whatnot, so I was in pretty good shape. But then you hear me speak, and it's like, okay, maybe this person really is a nerd, you know? Yeah, I'll see ya. Yeah, it is true to some people, yeah. Yeah. Yeah, it's like, what is it, the, jocks from Mobs P Psycho 100. I don't know, I'll have to find that later. I'll have to find a good clip, But it's like if those guys were like also programmers, that's kind of like how I would imagine it. So this index here, we're just gonna say int32 nextdex 444 next index. Okay, and next index equals this, right? So, and then if we're zooming in the other direction, the next index is going to be like a minus minus. Now, the problem here is that we could end up going out of bounds, right? So we want to make sure we're not out of bounds here. So the nice thing is, because we null terminated this list, right? So up here, we know when we're out of bounds because we end up negative, right? If we end up past the 0 up here. And then down here, we have a nice little null terminator. So if we hit 0, we know we're out of bounds that way, right? So we can just go into here and say, so this table here, let's go add this as a macro, because this table is a very long name here. So we're gonna just shove it in here. We're just gonna say define tab for table, right? And then we have this table macro here. And then down here, we're just gonna undef this table, right? And now what we can do is, when we're going minus minus, that's pretty easy, right? So if nextdex is then stop at, right? So if we try to go too far back, we're just going to stop here, right? So if we try to zoom, all the way out, we can't go any further out than the first index. And then else, if nextdex is less than 0, error 2021-02-27. So this is kind of weird, but the idea is that, you know, we're going to oh, and this is also wrong. This is a zoom in, and if we're going minus, we're zooming out because we're getting bigger camera sizes. So I have this actually inverted. So let's take this and flip this around. So we can make a note of this and say that larger camera sizes are near top of the array. Right, so we can make a note that the larger sizes are near the top of the array. So nextdex equals this index minus minus, and then cap at 0. And then over here, what we're going to do is we're going to use that table, right? So if table nextdex, and if this equals 0, so if 0 equals this, say 0x0, if that is the case, null terminator hit, and end of the list. Okay, so if we're here, then we're just going to say that nextdex plus plus, right? So we're going, ooh, not minus minus, so this is back up. Okay, yeah, so we're gonna back up there, right? So, so then, so let's indent this for a second. Actually, you know what? We're gonna steal this. So this is a different section, really, right? So this is snap camera to friendly size, and what we're currently writing is not that, right? So let's reorganize these sections, right? We want these sections to actually make sense for what we're doing. And so, move to next camera size. Or, get next camera size. So we want to get next camera size, right? That should actually be like that. Okay, so get next camera size, blah, 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 table. Okay, so we got this nextdex thing, right? And now to get the camera size, we just need to, go into that array, right? So this array right here, we can just steal it directly, and nextdex. And this is the new span, right? So where is the span variable here? So we have these variables, we get the width and the height, and then we get this span old, and then we get this new span, and we don't even use it, do we? Well, we have nextdex, so why don't we just call it next span, right? That would make sense. So, int32 next span equals 0 minus 222, and the next span and the old span is what it was originally here, right? And then what we're going to do is we're going to so this doesn't actually change the camera size. Okay, so we're just gonna say, right, so the next span is this, right? Okay, so we're gonna get the next camera size, and then, we need to figure out the delta, right, to make that happen, right? So, apply, delta to get, apply delta to achieve next camera size. Let's just call it apply delta. Yeah, so we now need to figure out what the delta is between the current camera size and the old camera size. Or, honestly, the easiest way to do this is to first, we have this thing here, right? So let's go take this for a second. And we're first going to, I'm gonna change my mind. We're gonna say apply camera changes. right? And we're going to do a put, right? Is that how we want to roll here? Because we could just do it all in one go here. Okay, no, we're not gonna do it all in one go. We're gonna yeah, maybe all in one go is the best way to do this. Let me think about it. Now we're gonna try it in, yeah, okay, so here's what we're gonna do. So x0, so x0 needs to be, so we have the span that goes in, right? So here's this kind of stuff here, and we figure out the old span, and then we have this new span, and the new span is snapping the camera to that nearest power of 2 thing. So let's just say, int32, old add to new, right, is going to equal convert to new. I'm going to say convert to new because it may be an addition or a subtraction. So we're going to say span old minus span, the old span minus the new span. And if old to new is less than 0, then, you know, old to new equals 0 minus old to new, right? So we're just going to take the absolute value here. Get absolute value between original camera size and the snapped camera size, right? So we're going to get this absolute value between the original camera size and the snapped camera size. So span new is the snapped camera size, right? And then what we're going to do is we got to figure out if we're shrinking, if we're zooming in or zooming out, right? So this right here, the zoom I32. So if it's negative, we're zooming out. Okay. So, and some of this is just ugly, but we want to get it working first, right? So if zoom I32 is less than 0, zooming out, grow rect, else so in one case we're going to grow the rectangle, the other case we're going to shrink the rectangle, and else error WTF man 2020-02-27 at 5 p.m. Okay. So we got this zoom thing. Negative is zooming out, right? Negative is zooming out, and we want to make the rectangle bigger. by going up that list. That looks good. Okay, cool. So now what we're going to do is we're just going to divide the int32 dx delta x and int32 dy delta y. Okay, and if we're zooming out, we're growing that rectangle, then delta x equals, ooh, do we need a delta, or do we just need to, we don't even need a delta, do we? Sure, we can have a delta, but we don't need to do it. Assert old convert to new modulus 2 equals 0. So, the delta should be divisible by 2, because to shrink or grow the rectangle, we need to pull or push both sides of the rectangle. Delta should always be divisible by 2, because must pull both sides of rectangle. Push, pull, push or pull both sides of the rectangle. Okay, right? So that's why we have this assert here. And then dx, right, can equal old convert to new divided by 2. So this is kind of redundant, where it's like, do we really need this much stuff? But yeah, then all we have to do is say that x0 equals, if we're zooming out, we're growing the rectangle, so x0 equals x0 plus u32 of dx. Okay. And because dx is divided by 2, right? So x1 equals, x1. Actually, hold on. If we're growing the rectangle, the left side needs to get bigger, right? My bad. And then x1 u32 dy, or sorry, dx, right? So plus. And then over here, we have y's. So y-axis, same deal, except it's y's. Okay. So pulling rectangle apart. Okay. And then over here, we're going to do the inverse, right? So if we want to shrink the rectangle, we're going to push the rectangle in. Push rectangle in on itself, right? So over here, the lower boundary is going to go up, and then the upper boundary is going to go down, so they're going to meet in the middle, right? So a plus minus, right? Plus and minus, plus and minus. So we just got to flip the signs there. dx, dy, x0, x1, x... Yeah, okay, so that looks all good to me. We might want to color code things really quick and make sure that everything kind of checks out here. So first of all, when we look at the x's and y's, that the colors kind of line up. And then also, if we want to look at the zeros and the ones, respectively, so the zeros and the ones, zeros and ones, oh, that's, hold on. Zeros and ones, zeros and ones, so the zeros and ones match up, and we see zeros are minus here and plus here for the ones, and and then it's inverted. Zeros are plus, ones are minus here. Okay, so that all looks good to me. So we've checked that. That looks good. So, so after we have this, we're going to put the new values, right? So this x0, whatever. Apply the camera snap, which is not the final camera size. But the this is not the final. Okay, so once we have that, we're going to use the zoom camera here. Okay. And zoom camera actually can take an actual delta, right? So actually I'm going to put this over here. And we're going to say apply camera snap, right? So we're going to apply the camera snap here. Okay. And then what we're going to do is we're going to apply zoom to final size. Must use helper function rather than set directly in case the camera is leaking off the bounds of the data set. Right. So yeah, so we're going to use this, and we need another delta, though, right? So we have to go, we need another delta, so we might want to collect some of these things here, right? So we have the old span, and then we have the new span, so we have new span here. Right, so, right, and then later, we get the next, we have new and next, which is kind of stupid, but that's what we've named things. So, the next dex, right, you have next dex, and then we have, sand next, right, so sand next. So let's actually just let's make a variable declaration section. Right, because right now everything is kind of like all over the place, and we would benefit from centralizing some of these declarations to know what are the actual variables that we're working with in these calculations here. Okay, so we're just gonna steal the things that we think are important. So let's steal these. Right. So this is original camera size given to function. Original input camera size, right? This is the original input camera size. And then snapped camera size and index in array. So we can make a note of this. We can say that it's this thing right here, right? So we can say this thing sandex, right, is the index in the array. And we can indent that as well. So we have this old span, and then we have span new and spandex, right? And then later on we have nextdex. So let's go look at that. So then we have nextdex, and we have next span, right? So get the camera size up or down depending on if positive or negative value was supplied. Let's just make a note here. Nextdex. Next camera index accessor. And then next span, next camera span slash size. Okay, I'm just making a note here because I'm about to move this stuff to another section, right? So, how's it going, anime dude? Let me throw this up here for a second. Yeah. So, you going to school yet? Or are you still being sick? Because I know you got out of school. Also, isn't like school supposed to be like under quarantine, or like isn't everyone supposed to be like not going to school anyways because of, you know, the plague? Oh yeah, that's right. Oh yeah. Yeah, I forget because I code every day. So, like, today was, you know, I had to go to the shop, but the shop, the machine that I wanted to use was broken down. But today is kind of like business as usual for me, so I kind of forget that this weekend thing exists. So, my bad, yeah, I totally forget, yeah, you'd think that I would know things like this, but sometimes I don't even know what day it is. I'm like, I know what day Monday is because I get to drink coffee on Monday, but besides that, I'm like, blah, I don't know. Like, it's, yeah. And I did also look up that, what was it, Charizard Mega? I actually did look that up. I don't know if I looked it up while you were here, but I was looking that up earlier. My girlfriend actually knew what that was. Yeah, I was looking this up earlier. Anyways, it's been a long time since I've played Pokemon. Honestly, the only game I play these days is Doom, because I only have room for one game, so I like to have like a very challenging, like super difficult kind of game. So, what is it? Is it Ultra Nightmare? No, just Nightmare. Like Gmod. I've heard the term Gmod, but I actually don't know what you're talking about. Gmod. Like, I've heard of it, and I probably know what it is if I see it, because I know... is Gmod the Half-Life thing, or is that something else? Is Gmod the Half-Life kind of thing, or is that something else? But if you have some links and can show me what you're talking about, I'll take a look at that. So yeah, the final camera size, we can't directly set this, but must do so indirectly by applying a camera delta. Also, we might want to make a note that 0159 and the time is 01:54 or 55 now. Okay. So right here, right, this next dex, so we go from the original span to the new span to the next span. So it's kind of like confusing because new and next are kind of like synonymous. But, oh well, that's kind of how we named it, right? We input this old span, we get out a new span, we directly snap to the new span, and then we use camera control helper functions to get the delta from the new span. We get the delta from the new span that we snap to the final span that we want to hit, and we apply a delta to get there rather than directly input that value so that our camera helper functions can help us with that. So next index, and this is next span. It's a sandbox game. Yeah, I'm familiar with the idea of like a sandbox, but I'm trying to add... oh, you mean... hold on. Maybe I don't understand what you mean by sandbox. So there's sandbox in terms of security, but then there's also, what, sandbox in terms of like creativity? Yeah, because Minecraft counts as a sandbox game, right? Non-linear gameplay, Terraria. So I'm familiar with Terraria. I am familiar with Minecraft. I guess technically you could think of Grand Theft Auto as a sandbox game. I guess that would make sense. What does Wikipedia say on that? Sandbox game, a video game with the gameplay element that gives the player a great degree of creativity to complete tasks towards a goal within the game, if such a goal exists. So it may not even have a goal, right? So basically, very loosely structured or unstructured. Got it. Gary's mod is Gmod. Yeah, Gary's mod. Yeah, that's what I'm thinking. Let's go look at that for... because that's the Half-Life thing, right? Gary's mod. Oh, maybe that's not Half-Life, that's is this Team Fortress 2? We go take a look at this. It's like... Come on, load internet. Yeah, Team Fortress 2, Gary's mod. Unbridled experimentation, intuitive learning, beyond the sandbox. Okay, physics sandbox. There aren't any predefined aims or goals. All right, I'll probably have to like maybe watch some videos sometimes. Yeah, I have my friends used to play Team Fortress 2. So I am familiar with Team Fortress 2, where like. I forgot, well, you got the spy, you got the tank, you got the flamethrower guy, and I don't know who else you have. I just remember those 3 characters. Because they had those, like, really interesting, like, Meet the Spy or whatever the heck video. Like, what? Meet the Spy, right? They had a whole bunch of, like, yeah, like this kind of stuff.
Intruder! Red spies in the base.
Red spies in the base.
Protect the briefcase.
We need to protect the briefcase.
Yo, a little help here?
I got it. Stand back, son. One.
Hey, it's still here.
Gentlemen, I see the briefcase is safe.
Safe and
Yeah, it
sound.
is.
Tell me, did anyone happen to kill a red spy on the way here? No? Then we still have a problem.
And a knife.
Ooh, big problem. I killed plenty of spies. The dime a dozen backstabbing scumbags. Like you. Ow. No offense.
If you managed to kill them, I assure you they were not like me. And nothing like the man loosed inside this building.
What are you, president of his fan club?
No. That would be your mother.
What the? Wait,
Indeed. And now he's here to us. So listen up, boy. Or pornography starring your mother will be the second worst thing that happens to you today.
Oh! Give me that!
The spy has already breached our defenses. You've seen what he's done to our colleagues. And worst of all, he could be any one of us. He could be in this very room. He could be you. He could be me. He could even be...
Whoa, whoa, whoa! What? It was obvious. He's the red spy. Watch. He'll turn red any second now. Any second now. See? Red! Oh, wait. That's blood.
So, we still got problem.
Big problem. All right. Who's ready to go find the spy?
Right behind you.
Alright, anyways. Overpowered. I'll take your word for it. I haven't played Team Fortress 2. I just watched my friends play it. But like, I don't know. They were always like playing it in school, and I was like, when I was in school, I was actually doing work. I don't know. If I was not working, I was like outside doing something, because, you know, you program all the time, and it's like, I don't know, sometimes it's like you want to actually go outside rather than play on a computer more when you're kind of like coding all the time, if that makes sense. Okay, so we got these things here, and let's just look at this right here. So this right here is where we're setting this. And then we need to get a delta between, not this, because we're going to take the old span and the new span. We're going to get a delta, dx, dy. Hold on. dx and dy. Oh, geez. Yx, that's not even a variable. Let's highlight that for a second. So, dy. And this right here is also a dy. My bad. Can't believe It's nice to kind of glance over code more than once, because there's plenty of stupid things I do. Okay, so after we apply this camera snap, right, so we're going to adjust these boundaries of the camera, and then we're going to store that camera in the texture memory right here. Technically, this is not the texture memory, it's a CPU side bitmap that is synced with the texture, but good enough. We can just say texture memory. That from a high level, that's kind of what's going on. After we've put this camera size, we are now at the new camera size. Now hold on. Okay, yeah, got it. So we could also do a getter, right? So we could do a getter here. And well, actually, we can assume this. I'm going to assume this getter works. I already kind of wrote enough tests for this that I know it works. But one thing we might want to say is this is the new span right here. So that means that if everything works out correctly, int32 span check x equals x1 minus x0 plus 1. And then for the y check, let's just make sure that it's correct, right? So, you know, if span check x is not equal to this, and we can do this because this has no correction code in it. It directly sets these values. It does not do any type of modification, like making any bounds checking or anything like that. So the span check for the y, okay, and then we're just gonna say if we get here, error, your math is off. And the year is what? So 2021, 0227, 5:27 p.m. There. So just make a very specific error message. We don't really care about the contents of the error message. We just care that it's kind of unique enough that we can find it later. Okay, so we've checked the span, and we've, you know, set these values. So now we're pretty sure we've applied this camera snap correctly if we get down to here. So the next part is we need to apply some type of modified value, another delta actually, and to apply this delta, we need to just go from int32 vec about new actually okay, we're going to take new and we're going to add to get to next, right? So to go from new to next, to create a vector in this direction, all right, then we need to take the next minus the new, right? In int32, so A2, what does A2 stand for? So A2, add 2. Vector pointing from make vector pointing from new to next, right? So we're pointing from we're pointing from new to next, and to go from the new to the next, we use this add to value, right? So this zoom camera thing is now going to be this value, right? Now, does that actually make sense, or do we have things backwards? Are we inverting this? So we may want to flip this, because the zoom camera, to get to the next size, things might be kind of like inverted on us. So let's go look at right, so negative is zooming out. Negative is zooming out, but we're increasing the rectangle size, right? Okay. Okay. This is kind of convoluted. But we have to actually flip this around because of the conventions of how the zoom camera thing works, right? So if the delta is trying to make the camera grow larger, then it's going to be a positive value, right? And if it's a positive value to make the camera grow larger, well, positive zooms in, it shrinks the rectangle, right? So we need to flip it. We just need to flip this value in order to get that to work correctly. So, oh boy, that is a lot of code. I am scared. So the first thing is we want to make sure this compiles, because I'm sure that we have some mistakes in here that are going to cause this to just not compile in the first place. Also, let's explain this. For the camera, right? So at 1:59, and the time is 02:10 or 02:11. And let's say I make it a 13 to keep the conspiracies. Okay, so let's explain this right now for the camera. Okay, so to apply the final zoom size, we need to get a vector that points from the snapped size, which is called new, to the next size, which is called next, right? New to next, and A2 is for add to. So this is a vector going from new to next. And to get a vector going from new to next, we have to take next, and we have to subtract new, and then we get a vector pointing in that direction. You could also think of this as a delta. So now we have a problem where if this is positive, it's going to grow the rectangle and it's going to zoom out, right? So growing the rectangle and zooming out. However, we see that positive here zooms in and it shrinks the rectangle, right? So the convention for this is inverted to what the actual delta in the inner workings is. So we have to take this vector and we actually have to invert it. Because of how zoom camera works, right? So the idea was that zooming in was, to zoom, if you give it positive zoom values, you're kind of increasing zoom, like 1x zoom, 2x zoom, etc. And then to zoom backwards, you would give it a negative. And that's why the zoom takes this kind of value. But in the inner workings, as far as inner workings are concerned, to zoom out, you actually increase the rectangle size. But the way the interface works is flippity-floppity. So that's a horrible explanation. I tried. I guess the best I can do is try. Let's actually review some of the other code, make sure that all of the code kind of makes sense before we give it a run. So over here, apply camera snap. So we have an old to new. So we have the old span minus the new span. And I don't know, is this supposed to be a vector or what is this supposed to be? So we are assuming that, because it's not pointing in that direction, right? Are we adding it? So this vector doesn't... So first of all, if we want to take the old span, right, we're modifying the old span. Oh, we're taking we don't got to worry because it's an absolute value here, so we don't got to worry about that. Okay, it's an absolute value, so you don't have to worry about which one's minusing from which here. It's just called convert to, right? So it's not add to or subtract. It's not an add to or subtract to. It's C2 for convert to. And if it goes negative, we flip it around. We make sure it's positive, right? So we can assert. We might want to assert here that old C2 new is greater than or equal to 0, right? Okay, so once we have this, it needs to be divisible by 2. And then we're going to divide it by 2 because we're going to apply the delta x and delta y to their respective edges of that rectangle, right? And so if the zoom value is negative, then we're zooming out, right? And to zoom out, we grow the rectangle, right? So negative, zoom out. So the left edge gets pulled to the left, the right edge gets pulled to the right. The top edge gets pulled up, the bottom edge gets pulled down, right? If we're zooming in, though, we got to shrink the rectangle, right? So if the zoom is a positive, then we're zooming in, and the right edge needs to be pulled in towards the center by moving it to the right. I may have said that wrong. This is the... Sorry, I get my left and right edge mixed up. So this is the left... towards the center, and this x1 is the right, and we're not moving it towards the center, we're going negative, so it's going away from the center. Okay, right is also moving away from the center, right? So it's the right edge is moving this way, so we're going here from the center. Actually, let's just diagram this, right? So, x0 is kind of going like this way, and here is the, and then over here is the center of the rectangle, right? And then x1 is going like this, right? So we're pulling it apart, right? And it's the same thing with the y, right? So the y does the same idea for the y, right? So, but it's not actually horizontal, but we're not going to draw it like that, right? So we're pulling it apart. So this goes over to the left. This goes over to the right. Same thing for the y, right? So then when we're over here, right, we want to do the other thing, right? So we're going to move this in towards the center, right? So we're going to do something like this, right? So, yeah, we're going to move that in towards the center. So the x0 gets plussed, right? And the y1 gets minused. And then same thing with the y0 is the bottom bound, is the top bound. And, hold on. Do I have y's inverted here? Oh no, because y0, in order to move towards the center, it needs to increase, right? Because the top of the screen is 0, the bottom of the screen is some high value. Okay, yep, that makes sense. Just making sure I didn't get that inverted. Okay, cool. So that looks correct. Okay, so once we figured out the new kind of value to snap the camera, we're going to directly modify that value here, right? So put that here. The other problem I'm seeing here is that what if this value goes like too large or something, right? Let's just add some checking here, right? Instead of directly doing this, we're going to say we just want to make sure, absolutely sure that that we don't go negative, right? So So none of these values should ever go negative. We don't have to really check all of it, but error okay. And then what we're going to do here is we're going to create a, we're just going to call this snapped, right? Because apply camera snap. Okay. And then over here, we're going to, instead of casting this to U32, this is going to be int32. And we don't actually need the cast anymore, but the thing is that I just don't want to have to rewrite it. So this, however, gets an int32 cast, right? So we want to do this with unsigned value, with signed values now. And then over here, same deal. This is going to be int32 cast of this. All right, so these values. Okay, and we'll declare the snapped value here, right? So we're going to say, you know, int32 snapped x0 equals 0 minus 111, or some type of trap value in case we forget to set it. And it's x's and then y's, zeros and ones. And then we'll just do like 2, 3, and 4, right? Just set that to some trap values. Okay. And then what we're going to do is after we figure out what the snapped value is supposed to be, we're just going to say that, x0 equals the snapped x0. And then we're going to do the same thing for everything else. So x's and y's, zeros and ones. And then steal this and put it over here, right? So if we highlight these, we should get like unique colors for everything. Right, and all these colors should line up with each other, right? Okay, so we got the snapped value, and we're going to apply the camera snap here. And then we're also going to check the span, right? So we're just going to make absolutely sure that these values have the new span, right? The snapped span. Okay, cool. So that looks correct to me. I think that's good enough for this section. And we're just going to say 59. 32. So before this timestamp is when we explain what was going on. So you'll have to go back through the video if you want an explanation on what the camera snap code does and how it works. I'm pretty sure that's good now. So let's go to the next camera size. So next camera size, let's make a note of this, right? So let's start to explain this and not forget about it this time. So 159, and the time is 2 minutes, 23 seconds, and how about 23 minutes, 13 seconds. And we're going to start explaining what's going on here. So this is just a macro for this table. So this table right here that gives us all of the camera sizes we'd like to snap between when we're using the camera. This feels like way too convoluted of complicated code, but oh well, it's what it is. So right here, if the zoom value that was inputted originally, I believe, yeah, the zoom value, if that original value was a negative value, then we're zooming out, right? So we're making the rectangle larger, right? So if we see this san dex minus minus, that is because over here, minus minus, when we go negative, we go up to higher and higher values, right? So that's how we're zooming out, right? Because zoom out, negative is for zooming out. And so we want to make sure that the next index, we want to stop at 0, right? So if we're equal to -1, we want to cap it at 0. If we're even further negative than -1, then we have a more serious problem. Okay, so if the zoom value is positive, then we're zooming in. And if we are zooming in, we're making the rectangle smaller. So the next decks, we're going to take these sand decks, and we're going to plus plus, right? So we're going to go from a larger camera size down to a smaller camera size, and that creates a zoom in. And then we want to make absolutely sure we're not on the null terminator, right? So if we're on the null terminator, we're going to have to back up once. So next dex is this plus plus. And we can back up 1 if we went too far. And there's a null terminator on the data right here. So it needs to be null terminated, otherwise this will crash on us. Okay, so that looks good to me. And then after we've done that, this next dex here, sand next equals next dex, right? So the span that correlates to this next dex is whatever we get out of here. Okay, and then sand next, where are you used? So are you used down here anywhere, or? Okay, sand next is all the way over here. So I feel like I might be getting values, get next camera size. Oh, okay, got ya. So we're doing things in terms of oh, I see. So we get the camera size, edit cam, and snap. So we take this old thing, and we want to get the new value, right? So we have new. This new value is snapped, right? So sandex right here. This is the new value. And this is the thing that comes after next. And then we apply it here. Okay. So this is the next camera. This is the next camera size after snap. So this is the next camera size after the snap is what this is. Okay. And what else do we have? I don't know. This is crazy. This is ridiculously crazy code. Now, we're not actually calling this anywhere yet. It's just we're trying to get the logic correct. So we're going to take a look at that, and we're going to make sure we can still compile. We may have some type of syntax errors. And then after that, we're going to try to give it a roll and see if we can actually make this work. With undeclared. So let's go find that. So let's go look for Control F width and width and height. Oh, because we copied that from somewhere. I know I used this somewhere. So let's, I know I wrote this and then I moved things around, so what the heck, where are they? Oh, here they are. So the span old, yeah, so my bad. This span old needs to be snapping cam. That's an int32. This is an I32 with their height. Yeah, so that's actually the correct calculation. It's just that we need to put it where it actually belongs. So this right here, before we call this, right, we need to say that, you know, right, we have this width, we have this height, and we check it here, and then san old equals this, right? So san old is int32. Old input span, and then this right here is the new input span, right? And then sandex, the usage is this, right? And, okay, cool. Do we think we're ready? I think we're ready to keep on trying to compile, and then hopefully, once we fix all of the compile time errors, the actual code for the camera, when we put it where it belongs, will just work. Sannext is undeclared, so let's go find sannext and figure out what's that. So int32 sannext and int32 dexsan, or sannext. Nextdex. Oh, I see. So anywhere we see san next, we're going to place it with next san, right? Okay. Sannext and nextdex. Let's go look for that in here for a second. Match the whole word here. How about dex next? Okay. So we're going to add, we're going to go add this into our shortcuts here. So next dex and next san, right? So next dex, right? So if we type this, then I want that to, you know, show me that. And then if we type something similar, we're going to say that autocorrect it. And then if we do something backwards, right? So if we do like dex next or dex next, dex next, dex next, dex next. Backwards, use next dex, not. And this is kind of grandfathered in, right? So we've just decided on this name for this. So we just want to stick to one thing and use it. So then we want like a definition. So next dex, what does that mean, right? And next dex, next index. Okay. And now we want to get a Farc template. I'm going to get our little template here. We want to take all this code. And we have next dex, and then we have next span, right? So we're going to take this, and where we see dex, we're going to replace it with span, so that we can get all the shortcuts we need for the next section, right? Without having to do all this typing again, right? So run that. And now we have next span, and if we try to do something that is span and next, right? Span and next, we're going to say that's wrong. And then this is, oh, what's this? Yeah, hold on, I'll explain. Next, SPA, next span. Okay, and then I'm going to just put a little section divider in here. Yeah, so, yeah, I have a master shortcut script I wrote in AutoHotkey, so I can demonstrate that. For instance, if I type, like, how about, dragon. I might have to do dragon kanji, because it's been, yeah, so, if I do dragon kanji, right, we get a little dragon, right? If I do, like, what else do we have? Right, my shortcuts, right, if I type frog, there's a frog. It doesn't just work for kanji, right? I'm just demonstrating it, right? So if I use unicorn, get a unicorn. If I use a table flip, there's my table flip. If I do TF01, table flip number 1, table flip 02, table flip 03, right? So I have a whole bunch of table flip 04. That's actually putting down the table. Table flip 05, let's keep on going. Table flip 06. Right, so, like, I have, like, a whole bunch of, like, let's keep on, how many of these do I have? 07? Okay, I think I have up to 6, right? So, I have a big, gigantic script of a whole bunch of shortcuts, and I have been working on this shortcut script for over 3 years. So, anytime I find something interesting, I put it in the shortcut script. So, I only can read some Korean. I can't read Korean. And as far as kanji goes, it's just that I memorize some of the kanji that I'm interested in, but I don't know enough to, like, actually, like, read, like, a newspaper or something. The idea of Kanji Coder was that I was naming classes using kanji at one point in time to make some, like, really terse code, right? So my my command line, I had a command line class, and its code name was Dragon, right? And the idea of this was, if I use kanji for, yeah, kanji is difficult. Now, kanji are composed of radixes. So, for instance, if we take this one here, so we take dragon right here, that looks like it is, it's been a while, but it should be stand, right, plus, and then there's another radix right here, so the radix underneath this, and I think that's electricity. No. Electricity still has that other kanji. I don't, what is it? Stand plus something or other. What the heck is that? It's not a rice field, right? Because a rice field is like, it looks similar, but it doesn't have the little tail on it, right? So a lot of very simple kanji are used to build the more complicated kanji. God, what the heck was it? Dragon plus... we can look it up, though. We can just look it up. Let's go look it up for a second. So, if we put a dragon kanji in here, it should... It doesn't always tell us the radicals, but most of the time it does. So, if we put dragon in here, and we look at this, the radicals... It isn't telling what that radical is. Well, let's click this. Maybe we can, in the details. Okay, so here's stand, right? Here's the stand, and then, yeah, it has the rice field, but I swear that this kanji here, it's not just a rice field. It has a little hook, and I don't think that means rice field. I think it means... Sometimes when they do this breakdown, it's not the best, I don't think. I'm sure if I was a native Japanese speaker, it would make more sense to me. Let's go look at the radicals, because I know we should probably be able to find this in the radicals. Right, so these are all the smaller parts that kind of make up the larger parts. So we have this dragon radical, but there should be a smaller thing over here. Now, if we're lucky... we might already have a shortcut that will explode this for us. So let's actually try that for a second. Explode dragon. Well, actually can't do that. Explode dragon. Nope. Dragon explode, probably not. Explode dragon kanji. Dragon kanji explode. So we're gonna take some time to actually look for that for a second and figure out what the composite parts are. We already know what that first part is, but I feel that we can actually find explode kanji. Let's see if we can find a better source for actually exploding. So this used to work. Let's just look for. So this had a tool somewhere that would kind of like do like a radical. Let's just say explode kanji radicals, or break kanji into radicals. Right, so radicals are the subcomponents, and I used to use that site, but I can no longer find where that is. It's like when you know what the radical is, it's easy, but then when you're trying to like find yeah, and this is the part where, like, you know, once you have a symbol memorized, you're okay. But if you don't know what it is and you're looking for it, good luck. But that's why, like, you know, every grade has to learn like I don't know, like 1,000 different kanji for every single grade, which is crazy. But you can see why they would have to do that. But also, if you know the phonetics for the kanji you're looking for, then you can also find it a little bit easier, or the radical you're looking for, because every radical has a sound associated with it as well. Yeah, I can't figure that out. Actually, din. I think din. Let me just guess around for a second. Now I'm curious. Din. How about electricity? Electricity also has this, so let's go maybe look at that and see if maybe maybe if we split apart this one, it'll give us a better the radicals. Come on, maybe we can find this radical here. Or is it still going to tell us that that radical down there is a rice field? So rain, yeah, I know that's rain, but then this is telling me that this is a rice field. But if we look at that, it has a little hook on it, right? So the thing that throws me off is, yeah, it says this bottom radical is a rice field, but it clearly has like a hook on it. Turtle. Turtle also has this little hook, right? So you can see this kind of hook here. So it has this thing that they're calling a rice field, right? So they're saying that this bottom thing is a rice field, but we see this hook, which confuses the hell out of me. Yeah, I don't know. Obviously, I should just study more, or else I won't be able to, yeah. Let's leave that for another time, because I can't figure it out. But you get the idea, right? So they're saying that that little hook thing, I really feel like we can find that actual hook somewhere, though. So now I'm obsessed here. Break kanji into its components. There are utilities for this. But it's just the but there was, okay, let's use this. So we might have better luck with Chinese. Character decomposition is what we're looking for. This looks somewhat promising, where we have like a little inheritance kind of tree here, right? So you can see how everything's made. But where the heck is the... Do we have a way to... Well, let's just go Control F and see if maybe we can look out. No, we can't. Search. Let's go search for a second. And, I actually don't know if this is the correct place to put this. No. This is not Japanese, though. This is like Chinese. Characters. Let's just throw this in here. And no dice. It, like, looks like it blew up on me. Let's go... Right, so here's this, like, rice field, right? So if we select this little rice field thing, yeah, what the hell? Yeah, I just find that very weird that some things are, like, if you're not a native speaker of a language, sometimes you don't know what a stylization is and what is actually a different character, right? So it seems to me like the rice field with a little hook on it is still a rice field, but it's just a different stylization of it. But it seems like this UI is kind of broken. Decompose, maybe? Okay, I'm giving up. I'm giving up for now. Korean, I think, is more easier. It has only... Yeah, the... Korean is phonetic. Yeah, Korean is phonetic, which makes less to memorize. So we know that it's dragon equals stand plus rice field, even though it doesn't look that way. So yeah, we'll just make a note here for next time in case I try to look for this, that I actually did look into that, but we're giving up for now because we actually just want to get our code working. So we got all this craziness. Let's just try to get this. Did we change around that variable? Did we refactor that? I believe we did. Passing argument 4 makes integer from pointer without a cast. Oh, you know what? Did we cut and paste a function call? So we got this getter, which should be that, but then later we do a putter, don't we? Yeah, this put value. So this putter here, the putter doesn't use the address, right? It uses the actual value. So let's remove the address operator from that. Okay, let's give that a shot now. And this is ridiculous. This is like camera resizing code. Like, you wouldn't think that... I mean, this is a polishing aspect built on top of the camera code, so it's like, okay, maybe... But still, that's kind of ridiculous what we're doing. Okay, so now that it's compiling, it's now time to just take this little helper function. Right, so this PAINT5D zoom camera, and then we have this thing called use EDITCAM, right? So we're going to go figure out where this is being called from, and we're going to use it. So on mouse scroll. So this is the on mouse scroll. So we're just going to we're going to take this value, and we actually want to make this, this value, right, that we're looking at, this mouse wheel amount, this is actually bad anyways, because this is, we're supposed to be using this object here, right? We're not supposed to be using this. Mouse wheel notches. The mouse wheel notches are supposed to be coming in from here. So this is already bad. But yeah, we want to go like, so first of all, negative is out, right? So negative is out. And positive is, and this is mouse wheel notches is right, these two things are equal, but at some point in time we might actually only give it this instance and not this actual thing. So this is not good. Let's not do this. Okay, so let's comment this out. And let's also comment this out. And it's because it works now, because this value here, this input is set by copying some global state, this global state, but that's not always going to be the case, so this would be wrong in some cases in the future. So we're going to comment that out, right? So, and we might want to make a note of why that's wrong as well. So this we're just going to do is 0 plus 1, right? Because positive is zooming in. Then over here we're going to paste this down, and this is going to be a 0 minus 1, right? So negative is zooming out. And let's just make a note here. At vid IID. And it's 1:59. And the time is 2 hours, 52 minutes, and 42 seconds to be cool. Don't use here. While object is created at the moment by copying from the file scope variable. That will not always be the case. The whole idea of having a temporary mouse is this thing here. Actually points to it's well way up here. This thing. So the whole point of having this mouse slash struct is to decouple the file scope state from this function. Okay. Okay, so zoom camera, and now we have this new zoom camera. So this is the zoom camera function, and then it has an overload called use, and we're going to use the EDITCAM code, right? So let's give that a roll and see if we can get this working. And we'll know if it's working because, well, it won't crash on us, and it'll also behave in a better way. And I have no clue if this is going to work or not. I'm kind of scared right now. Let's just go over here. Let's press 1. Let's do P for pattern, and let's go to a pattern that makes sense. And then it blew up on us immediately. Assertion failed. So the first thing is, well, where did this assertion fail? EDITCAM.f line 62. Okay, so the good thing is that the failure is happening with an assertion, but so that we can kind of look this up, figure out where that's happening, and then we can fix it. So assertion failed on line 62 of EDITCAM.f, right? So if we go into EDITCAM.f and we find 62, the first thing I'm going to do is I'm just going to, well, that's obviously wrong. Minimum span greater than equal to max span. That's just nonsense, right? The camera span needs to be greater than or equal to this span, right? The camera span needs to be less than or equal to the min span. That's correct. But the min span, we could say that max span is greater than or equal to min span like that, right? Also, since we already got this wrong, we're going to change it from an assert to a more formal thing, right? So if 0 or these cases here, right? So if we get any of these cases, and if we want to be really paranoid, right? If we want to be really paranoid, we can put these in parentheses to make sure that it's that or that or that, and just say error, EDITCAM, failure, EDITCAM, bad inputs, year 2020, 2021. And this also will need a error macro here. So we're going to define error as AAC 2020, EDITCAM halt, right? So right here. And then down at the bottom of this, we're going to also say undef error. And then we're going to put this in the checksum, and we're going to give that another run. So what we're hoping for is that all of the mistakes we've made are completely stupid mistakes, and once we fix the stupid mistakes that hopefully are caught by runtime assertions, that the code will just work properly. That's what we're going to hope for, because if anything else, then we may have to write some tests or things to get things working. So over here, let's just do P for pattern, and let's go use the last pattern because I like that. And let's, no. Okay, so it says bad inputs. So now that it says bad inputs and we can see that message, the next thing is, well, what the heck is going on here? What the heck are our inputs? So let's just say we gotta printf the spans, right? So we have the max span. Actually, let's do the camera span first, right? %d \n and the cam span, right? And then we want all these other things, right? So we can take these and we can just paste them in here like this. And then maybe we want to printf and \n, right? Make ourselves some space and then give this another roll and see what those values are. Like, why the heck is this not correct? Like, what's going in here? So the idea is that we're going to take the camera and we're going to snap it between the min and the max. And when we're snapping between the min and the max, the value that we should have in the first place should already be between that min and max, and if it's not, then we have a problem. So let's go over here, P for pattern, let's find a pattern that we can zoom into, and let's run this again. It fails, and it says the camera span is 256, and this is cam span again. What the hell? What the hell is my problem here? Because we selected from here. Okay. I see. Oh, hold on. Okay, so I see what I'm doing wrong here. We're going to come back to this, but I need to take a quick break. So I'm going to take a quick break. I'll be right back. Let's do like 10 minutes. Yeah, let's do a 10-minute break. Looks like I have to clean the kitchen, so I have to go. So this stuff is wrong here, right? So let's just make an error here. Assert code below is broken. Fix it. So we need to fix this code, and we also need to change this to. We have the. We really want to do cam san. Then we want to do min. Right, we want to keep the same order as what is going into this, right? So these values here are going to go in. We're going to see what they are, right? And then the max needs to be greater than the min. Alternatively, the min span is less than or equal to the max span, right? So, relative to each other, check. And then over here, the camera span needs to be greater than the min span. The camera span needs to be less than or equal to the max span, right? So we're just going to break that apart a little bit so that when we're looking at this, we don't think that these lines of code correspond directly to these lines of code, because that's where we're making our mistake. And I'm just going to commit this. Camera camera polish work not done. Okay. So we're not done here yet, but I have to go. So, yeah, I gotta go. So I'll see you when I see you, whenever that is. But I'm out of here later. So this was video number 159 for Saturday. Yeah.